Many roads may look the same once completed, but the lifespan of each road is determined by moments during construction that cannot be seen. Every millimeter of elevation, every vibration cycle, and every layer of material placed are technical decisions that are vital to the entire structure. Road construction today is a technological challenge. Controlling elevation in real time, optimizing materials, reducing risks to people, and ensuring long-term stability for the entire structure. It is no longer a story of human labor alone, but a precise coordination between machinery, data, and engineering. In this video, Mandarin Tech will explore with you the modern road construction technologies, the factors that quietly determine the lifespan and durability of the roads we travel on every day. GOMACO GP4. GOMACO GP4 is a large, self-propelled, slip-form concrete paver designed to construct monolithic concrete pavements in a single continuous pass. Instead of dividing the work into multiple separate steps, the GP4 integrates material feeding, distribution, vibration, shaping, and surface finishing into one continuous process. When the machine begins operating, fresh concrete is fed into the front of the GP4. Here, horizontal augers extending across the width of the machine pull and distribute the concrete evenly across the paving width, which can reach up to 38 feet. Immediately afterward, the concrete passes through a high-powered vibration system where it is compacted, air bubbles are removed, and a uniform density is achieved. Next comes the slip-form mold, the most critical component of the GP4. As the machine moves forward, the slip form slides over the concrete, pressing the material into the precise shape of the pavement cross-section. Thanks to this mechanism, the concrete is shaped without the need for traditional formwork. At the rear of the machine, the finished concrete surface appears almost immediately, flat, continuous, and true to design. The contrast between the rough, unfinished concrete at the front of the machine and the smooth, finished surface at the rear often gives the impression that the GP4 is performing two different tasks, when in reality these are simply two consecutive stages of the same process. The GOMACO GP4 is particularly well suited for highways and airport runways, where durable concrete surfaces with minimal joints and consistent quality are required over stretches spanning many kilometers. SLJ 900. SLJ 900 is a specialized piece of equipment developed by China's Huaojoint, designed to install precast bridge spans of extremely large size and weight. Instead of constructing bridges in small segments or casting concrete in place at height, entire bridge spans are prefabricated in a factory to match the exact length between two bridge piers. Once the bridge piers are completed, the SLJ 900 begins the installation process. First, the precast bridge spans are transported to the site and placed on temporary supports. The SLJ 900 then moves underneath the span, operating as a mobile lifting platform. The machine's hydraulic lifting system gradually raises the entire bridge span off the temporary supports, bringing the structure into a ready-to-move state. What makes the SLJ 900 distinctive is its high degree of mobility. The machine uses 64 wheels arranged into 4 groups, with each wheel capable of rotating independently by 90 degrees. This allows the machine to move longitudinally along the bridge alignment while also shifting laterally to precisely align the span with the design axis. These movements occur slowly, smoothly, and under strict control to prevent vibration or misalignment. When the bridge span reaches the correct position between the two piers, the SLJ 900 continues to push the span forward and places it precisely onto the permanent bearings. After installation is complete, the lifting system gradually lowers the load, transferring the entire weight of the bridge span onto the piers. This process is repeated for each span, enabling massive bridge segments to be installed continuously, accurately, and safely. Wave Delineator. Wave delineators are a modern traffic lane separation solution designed to create clear boundaries between traffic lanes while maintaining flexibility and safety in the event of a collision. Unlike traditional concrete curbs, wave delineators are typically made from flexible plastic materials with elastic properties and impact absorption, helping to reduce damage to vehicles and infrastructure during minor collisions. The most easily recognizable feature of wave delineators is their wave-like, undulating shape. This design is not only aesthetic but also enhances visibility, especially when combined with reflective strips or high-contrast colors. Wave delineators are widely used in urban areas, parking lots, bicycle lanes, traffic islands, temporary construction zones, and roadways that require flexible traffic organization. Roller barrier. The number of serious and fatal accidents related to roadside guardrails worldwide is showing an increasing trend. Among them, accidents involving vehicles leaving the roadway have long been a major concern for road safety. In response to this situation, ETI has developed a groundbreaking roller guardrail system that makes roads safer and helps prevent catastrophic accidents. The system is constructed from EVA, impact-absorbing material, a flexible and durable material capable of significantly reducing the severity of collisions. When a vehicle collides with the roller guardrail system, the rollers absorb the impact energy and convert it into rotational energy through 4 stages. First, the rollers deform due to their elastic properties, helping to dissipate the initial shock. Second, the guardrail beam continues to absorb the impact force. Third, the support posts further reduce the intensity of the impact. Finally, the outer guardrail beam absorbs the shock once again, thereby minimizing the force transmitted to the driver. At the same time, the rotation of the rollers, combined with their impact-absorbing capability, helps keep the vehicle in its lane and prevents secondary accidents such as running off the road or falling into hazardous areas. In cases where the posts or rail components are damaged due to an accident, only the damaged parts need to be replaced without dismantling the entire system, allowing for quick and easy maintenance. In addition, LED lights and reflective panels integrated into the rollers help drivers identify hazards such as curves and medians, even at night or in low visibility conditions. Road Printer Bricklaying Machine. Road Printer is one of the most advanced and unique paving technologies in the world today, delivering outstanding construction speed and near-perfect uniformity. Instead of placing individual bricks manually, the machine uses an inclined conveyor system where bricks are pre-arranged in rows at the rear, then gently slide down onto a pre-leveled surface, creating a finished roadway in a single pass. With an average output of 3,230, 5,280 square feet per day, the road printer requires only 2 to 3 operators, drastically reducing labor costs and construction errors. Its rigid steel frame, stable linear travel mechanism, and precise guiding system ensure a perfectly straight path throughout the entire paving length. The resulting brick surface is flat, even, and tightly jointed, requiring virtually no manual adjustments. Although the machine demands a level base and uniformly sized bricks to achieve optimal results, it is still regarded as a symbol of modern construction thinking, where paving is treated as an industrial production process, fast, synchronized, and precise down to the finest detail. Aluminum floating dock. The Canada Docks modular aluminum floating dock system was developed as a flexible infrastructure solution for small to medium-scale freshwater environments, including rivers, streams, inland lakes, canals, and areas where water levels fluctuate seasonally. Under such conditions, constructing fixed docks made of concrete or steel often faces significant limitations due to high costs, weak soil conditions, or the need for extensive intervention in the natural environment. Instead of creating a fixed structure rigidly anchored to the ground, Canada Docks system uses sealed, hollow aluminum modules that function as independent load-bearing floats. Each module has its own buoyancy and is designed to connect with other modules to form docks, working platforms, access ways, or water-based operational surfaces. When assembled into a complete system, loads are evenly distributed across the entire dock surface, ensuring structural stability and safety during use. These modules are manufactured from marine-grade aluminum, offering high corrosion resistance and the ability to withstand harsh environmental conditions, including seasonal freezing in cold climates. Inside each module is a sealed, watertight flotation chamber that allows the dock to maintain stable buoyancy throughout its service life. Another key feature lies in the system's modular design. Dock units can be assembled into various configurations, such as straight lines, L shapes, T shapes, or larger platforms, depending on actual usage requirements. When needs change, the entire system can be partially disassembled, reconfigured, or expanded without demolition. This makes the project an effective infrastructure solution for temporary installations, seasonal use, or remote locations that are difficult to access. Cold mix paving. Cold mix paving is considered a cost-effective and environmentally friendly alternative to hot mix asphalt. This process uses specialized paving machines to apply a mixture of aggregates and asphalt emulsion directly onto the existing road surface. There are two methods of cold mix paving. The first method uses a dedicated cold mix paver with an automatic screed system, allowing on-site mixing, in which aggregates and asphalt emulsion are mixed directly within the machine and laid onto the road surface at the designed thickness. After paving, the material layer is compacted using steel rollers or pneumatic tire rollers to achieve the required density, allowing the road to be open to traffic shortly afterward. The second method involves mixing at a central plant. The cold mix is pre-mixed using a pug mill, then transported to the construction site and laid using conventional paving equipment. Similar to the on-site mixing method, the placed material is compacted in multiple passes to achieve stability and load-bearing capacity before being open to traffic. Cold mix paving offers many advantages because the mixture does not require heating. As a result, transportation and heating costs are significantly reduced, making the process more sustainable through energy savings and reduced emissions. With its cost and sustainability advantages, cold mix paving is becoming a suitable choice for maintenance, upgrading, and extending the service life of existing road surfaces. Concrete curb machine. A concrete curb machine is one of the key pieces of equipment in modern transportation infrastructure construction, especially in urban roads, residential areas, parking lots, and highway projects. Instead of casting curbs using manual formwork, this type of machine allows continuous concrete curbs to be formed in place directly from fresh concrete with a very high level of precision and uniformity. Fresh concrete is continuously fed into the machine's forming chamber, where it is compressed and shaped through a fixed metal mold. As the machine moves slowly forward, the concrete mass is extruded behind it, maintaining the curb's shape through a balance between concrete slump, compaction pressure, and travel speed. The entire process is carried out without formwork, significantly shortening construction time. Concrete curb machines are typically designed as self-propelled units, using tracks or wheels to ensure stability across various subgrade conditions. The machine can produce different curb profiles, such as single curbs, curb and gutter sections, curbs for sidewalks or traffic islands, simply by changing the forming mold. This allows the equipment to adapt flexibly to different infrastructure design standards across countries. Compared with manual methods, curb machines significantly reduce geometric inaccuracies, minimize cracking caused by construction joints, and save labor as well as long-term operating costs. In large-scale projects, the use of concrete curb machines not only accelerates construction progress, but also improves the overall finishing quality of transportation systems. Road construction technology is not something people usually pay attention to, but a good road is never accidental. Building fast is something everyone wants, but how to make a road that deteriorates less, requires fewer repairs, and remains safe after many years of use. That is the real challenge engineers have to solve. Today, building roads is no longer simply about pouring concrete or laying asphalt and waiting for it to set. Machinery is becoming more precise, materials more durable, And every stage of construction is more tightly controlled to minimize errors from the very beginning. As a result, roads not only serve traffic more effectively, but also reduce maintenance costs and limit unnecessary disruptions to daily life. And if you want to explore more fascinating topics, follow Mandarin Tech. We will continue to tell the engineering stories that are quietly shaping the modern world.